Hey guys, welcome to the homework review on lesson 5.3. So I'm kind of going to go over one problem from each of the sets so that you guys can get practice or some extra notes from it. So the vocab guys, this is all you. Go ahead and match them up. So match the definitions with the actual word, vocab word. So let's take a look at a problem set 1. So all of these are going to pretty much be the same. They give you one example, number 1. So let's go ahead and do number 2 so you can see it completed step by step. So it says rewrite each function g of x in terms of the basic function f of x. So if we look over here, we stated that f of x is just equal to x, which means instead of writing x, we're going to write f of x, and that's essentially what we do in our function is completed. So if we were to look at number 2, we would just drop f of x here. Let's take a look at something a little bit more challenging like number 4. So in order for us to do number 4, we know that this x to the third power is really just f of x. So instead of writing x to the third power here, what we can do is just say g of x is equal to f of x and then plus 1. Remember that this plus 1 is a vertical shift, 1 unit up. And that's all we're doing. We're taking the f function and shifting it up once, or translating it up once. And that's essentially what we do for all of the problems in this set. Let's jump to number 7. Number 7 says to represent each vertical translation, g of x, using coordinates notation. So just to kind of annotate, vertical, in case you forget, means that we want to either go up or we want to go down. So number 7 is done for us, and something to keep in mind when we're working on these, we know we're working in our coordinate system, which is x and y. Remember, x controls the translations left and right, and y controls the translations up and down. So let's take a look at number 8. For number 8, if we want to write this in coordinate system, the only thing that's being affected, again, is this 9, and that's a vertical translation up-down. So the only value that's being affected is y. So we're going to write y plus 9 units. Meaning, that actually looks like an A, so let me rewrite that. Meaning that every y coordinate, we're going to add 9 to it because it's going to shift it up 9 units. And that's essentially what we do for this entire set. If we want to look at number 12, that's a bit harder one. Again, the only thing being affected here is the y. So we would write something along the lines as x and then y, and we're subtracting 5 units from that, and that's it. So let's look at number 13. Number 13 set says rewrite each function g of x in terms of the basic function f of x. So again, they give you number 13 as an example. So let's do number 14. We're going to rewrite g of x. We know that g of x, they gave it to us up here, is 3 to the power of x plus 5. This in turn, because we know that this f of x is 3 to the x power, we can rewrite this as the only thing changing here, instead of just having an x, we're adding that plus 5. And that's our answer. So we're just rewriting g of x in terms of f of x. And that's pretty much what we do for this entire set here. If we go down to the group 19 through 25, it says represent each horizontal translation g of x using coordinate notation. Remember, horizontal is either you're going, let's annotate, you're either going left or you're either going right. So something to remember or keep in mind is that whatever we have here, remember, like we talked in class, we have to do the opposite. So if this is -2, we're translating to the right, to +2. So let's look at number 20 and see if we can make sense out of that. So our coordinate system for f of x was just y, x, and y. Since we're messing with the horizontal translation, that's only going to affect our x coordinate. So this shift, it says +2, which means we're looking at our number line, 0 and 2, and we're thinking, oh, that's a +2, but remember, it has to be the opposite. So what we end up getting is a translation of x, negative 2 units, y, and we're done. This means that our graph will be translating 2 units to the left, not the right. So remember, we took those notes in class, guys. Make use of those notes, the notes that we wrote for this chapter. And essentially, that's what you do for these. For 25 through 30, this block, it says to describe each graph in relation to its basic function. Well, number 25, they give us the basic function. It's just h of x is equal to x, which we know is just a linear or a line. Now what they did is they said, all right, well, let's talk about all the b values that are less than 0. What would that do to this function? So if we were to rewrite this, and remember, numbers that are less than 0, those are my negative numbers. Negative. So if we were to rewrite this function is equal to some x, give it some negative value, negative 3. Then we can clearly see, oh, by example, we know it says the graph of f of x is b units below the graph of h of x. What we can write then is we have a vertical translation, or I like to call it vertical shift, 3 units down. To see another example of this, let's look at number 26. 26, again, we're looking at just the parent function, and we're just looking at a basic function, exponential function. And now we've included this c value, and we're saying when c is bigger than 0. So that's a positive number. Positive. So let's plug it in and see what that function will look like. If I plug in a positive value, we end up with 3, or b to the x minus 3. And remember, when it comes to these horizontal shifts, we do the opposite. So what we're going to be doing is we have a horizontal translation or shift 3 units. Since this is negative, we're going to do the opposite. 3 units right, to the right. That's essentially what we do for this entire block. Just keep in mind that we only do the opposite when it comes to those horizontal shifts, as we talked in class. Let's take a look at this block. It says each coordinate plane shows the graph of f of x, sketch g of x. So f of x is our original graph for 31. This has a vertical translation 2 units up, meaning we took the points and we went 2 units up. Here's 1 unit, here's the second unit. So as long as we can graph a few of these points and do the same thing, 1, 2, we can go ahead and make a connection and say, hey, 1, 2. Our graph becomes this one up here. So let me show you what that looks like for 32. We know that our y-intercept is at 0, 1. So we're going to shift this point, and again, this is another vertical shift or vertical translation, 4 units up. So let's go for up. 1, 2, 3, 4. Let's grab another point. This one looks like it's close to being 3 and 8. So let's go ahead and shift this point 3 units up. 4 units up. We're going to go 1, 2, 3, 4, somewhere here. The other trick that you can do is take the horizontal asymptote, which is our x-axis down here, and shift this entire x-axis 4 units up. So instead of being at 0, we're going to go 1, 2, 3, 4. Draw, use a straight edge. I don't have one, but you guys can. Our horizontal asymptote. And we know that our curve is going to look exactly the same. It's going to curve down here. It's going to get super duper close to it, but it's never going to touch. And that's our graph. You do the same for all the rest of them. And actually, number 37 is a little fun because, again, we have a vertical translation 5 units up. So we just take the points and go 5 units up and shift the entire graph, or translate the entire graph 5 units up. For this block, number 39 through 44, we're going to write the equation of the function given each translation. So now they're telling us what the translation is. We have to produce a new function. For 39, they told us the vertical translation up 2 units, so we just added 2 to it. For this one, we're going to have a vertical translation down 5 units. So again, if it's down, then we're thinking negative. We're going to say, okay, well, that's just g of x. Keep our basic function there, and we're going to subtract 5, and we're done. For the little bit tougher ones, number 42, we want a horizontal translation 6 units to the left. So remember, we have to do horizontal as side to side, and we have to do the opposite. So what this looks like, or this function, would be g of x is equal to 2x, and I know we want to write negative because it's going to the left, but we're actually going to write plus 6. And that becomes our answer. For 45 and the remaining of the block for your homework, each graph shows the function g of x as a translation of f of x. Write the equation. I believe we did not do these, or I did not assign these for you guys. And that wraps it up for the homework review. Hopefully this helped, guys. Remember, pause as you want, and you can rewind as many times as you want. Take good notes. Hope this helped. See ya.